and welcome back to my YouTube channel. Today I am going to explain Dijkstra algorithm. This algorithm is used to find the shortest path between nodes in a graph. I will explain this in a very easy way with examples and diagrams so even beginners can understand it. Let's start. Dijkstra's algorithm is a graph algorithm. It is used to find the shortest path, works on weighted graphs, and start from a single source node. Let's talk about the purpose of Dijkstra's algorithm. The main purpose of Dijkstra's algorithm is to find the shortest distance from a node to all the other nodes. It always chooses the smallest possible distance step by step. This helps us save time, cost and distance in real-life problems. Let's talk about the real-world applications. This is used in many real-world applications. For an example, Google Maps uses it to find the shortest route. GPS system uses it to avoid long paths. Network systems use it to send data in the fastest way. So the algorithm is not only theory, it is used in real life every day. Let's see graph basics. Nodes. Essential points that represent graph vertices. Edges. Connects nodes showing relationships or paths. Weight. Value assigned to edges indicating cost or distance. Key terminology. Let me explain some important words. Vertex, a point in a graph. Edge, a connection between two vertices. Weight means distance or the cost. Source node means the starting point of the graph. And then the shortest path means the smallest total distance. These words will be used again and again in this lesson. Let's see the workflow steps. This algorithm works step by step. First, we choose a starting node. Then we set distance of start node as 0. Then all the other distances as infinity. Visit the nearest unvisited node and then update the distances. We repeat this until all the nodes are visited. Here is an example graph for demonstration. A, B and C are the nodes and the edges and weights are A to B, the weight is 2, A to C, the weight is 4 and the B to C, the weight is 1. Our goal is to find the shortest path from A to all the other nodes. In here, when we start from A, the distance from A is 0 and all the other nodes are infinity. Then visit A, update B as 2 and update C as 4. Then visit the next smallest node. It means B equals 2. Update C, B equals 2 plus 1, that means 3, which is better than current, so C equals 3. Then visit C as shown in this table. Initialization of the algorithm. Distance to source node is 0 and distance to all the other nodes are equal to infinity. No nodes are visited at the beginning. Let's talk about the starting point of this algorithm. We start from the source node. This node is marked as visited. Then we check all its neighboring nodes and update their distances. Let's see the distance update. Now we calculate distances. If a new path is shorter than the old distance, we update it. This process is called relaxation. We always choose the node with the smallest distance next. The same steps continue. visit the nearest unvisited node, and then update the distances. Then mark it as visited. This repeats until all the nodes are processed. Final shortest path. At the end, we get the shortest path from the source node. We can clearly see the path taken, the total distance. This is the final output of this algorithm. Let's talk about the negative weight issues. This algorithm doesn't work with negative weights. If there is a negative value, the algorithm gives wrong results. For negative weights, we use other algorithms like Bellman-Ford. Negative edge. The negative edge can create loops or errors. The next one is algorithm limitations. This algorithm fails with negative weights. And the other one is pathfinding errors. Errors can occur when negative weights exist. Let's see the advantages. This algorithm has many advantages. The first one is easy to understand. And this is very accurate. Work well for many real-world problems. That's why it is widely used. But it also has some limitations. The first one is cannot handle negative weights, as we mentioned earlier. Can be slow for very large graphs. So we must choose the correct algorithm for each problem. As we discussed earlier, there are some limitations. No negative weights. This algorithm cannot handle negative weights. The second one is static graphs. That means this requires a static graph structure. Our third limitation is single source path. That means this algorithm only finds single source shortest paths. Let's discuss the technology applications. The algorithm is used in navigation systems, computer networks, game development and AI path finding. So it is very important in technology. As we mentioned earlier, it is very useful in GPS navigation. That means it enables real-time routing and location tracking. Our next point is network routing. Facilitate data transmission across connected devices. Then the transportation planning. That means it optimizes routes for efficient travel and logistics. Let's summarize what we have learned today. This algorithm finds shortest paths, work on weighted graphs, and uses greedy approach. And this does not support negative weights, as we mentioned earlier. I hope now you can understand this algorithm clearly. Thank you for watching my video. Please subscribe my channel and share this video with your friends.